Okay, welcome everyone. My name is Chris Gobler. I'm the director of the New York State Center for Clean Water Technology, and thank you for joining us virtually today. This is the first in a seminar series that we'll be giving. You can see here, we decide once a month, first Monday of each month, we'll be giving a seminar, and specifically on this particular seminar, I'm calling New York Center for Clean Water Technology, Innovating Solutions to Protect Our Most Vital Resource. And you can see throughout the rest of the year, first Monday of every month, you'll be able to join us virtually and live to observe the presentation and answer questions. For this particular presentation, I asked that you scribble down this email address, pretty straightforward, CCWT@stonybrook.edu. If you have questions during the talk, I specifically would ask that you email those questions during the talk to this address, and then those questions will be forwarded to me, and I'll do my best to answer as many of them as possible at the end of the talk. So again, CCWT@stonybrook.edu, use that and send it along, and I'll be happy to answer those questions to the best of my ability. Okay. I'm going to start out with this slide here and particularly talk about the idea of the watershed. And it's really this figure and this concept on which the entire center is based. So of course, the idea of a watershed is that any water that enters a given part of land will eventually make its way into groundwater or into surface waters. And then here, critically, on Long Island, our groundwater is our drinking water, and therefore that means that most of the materials that do end up on land will eventually end up in our aquifer, which is our sole source for drinking water. And you can see, as this figure here depicts, different activities on land, be it septic systems or agriculture or runoff from dense communities, those will have direct effects on our groundwater, potentially on our drinking water, and certainly also on our surface water. So, the idea of the water cycle is depicted here, and that's exactly what the Center for Clean Water Technology is really focused on. Understanding how the activities of man can affect these water sources and what we can do to make sure that our drinking water and our surface waters are as clean as possible. Now, unfortunately, living in a dense area like Long Island with more than 3 million people between Nassau and Suffolk County, there have been historically activities that have compromised the quality of our drinking water. So, for example, 1,4-dioxane is a probable carcinogen. It's been deemed such by EPA. It's an industrial solvent, also is enriched in household products. It's shown up at some very high levels. In fact, the highest levels ever recorded in the United States have shown up on Long Island. You can see this national map here, but you can also see that in New York State, where that cluster is, you can see the absolute highest concentrations are the ones that have been measured specifically in Long Island and Nassau County and Western Suffolk County. So this is a serious issue with regard to watershed contamination of our drinking water. And similarly, another compound, perfluorinated compounds, are also a human health concern, enriched in household products and firefighting foams, and also, unfortunately, enriched in many of our drinking water supplies. So you can see, again, you see many of these dots here that have come up, particularly now in this case, more eastern Long Island in Suffolk County than in Nassau County. And of course, we're probably most familiar with the nitrogen issue on Long Island. And this map figure here simply shows the growth of the population in Suffolk County through the 20th century. And in parallel, showing as we moved into this current century, the continual rise in the levels of nitrogen, specifically in the form of nitrate, in the groundwater, which is the drinking water, for Suffolk County, to now, I think just as of last year, the concentration on average is about 3.8 milligrams per liter. And we now know, the studies have been done over and over again, and that the source of the enrichment of nitrogen in our groundwater is primarily from wastewater. And maybe not surprising, we have a lot of agriculture in Suffolk County, but we have a lot more people. So population density is the big issue, and it's depicted in this figure here. There's significantly more nitrogen entering our groundwater from wastewater than there is from, say, fertilizer and other sources. And that's particularly the case for northern Nassau County and Suffolk County, because most of those populations are not sewered and instead have on-site systems. And so the depiction here of an on-site septic system being the big source, that is certainly the case for the biggest source in Suffolk County and northern Nassau County as well. So, just like those other compounds I already described, nitrate itself is a drinking water concern. Traditionally, most people, the EPA, for example, has ascribed the health effects from nitrate being particularly due to something known as blue baby syndrome. And that's why the standard is set at 10 milligrams per liter to avoid that from happening. But as it turns out, nitrate can have other health effects that we need to think about as well. And so, for example, I'll just very quickly introduce a compound known as nitrosamines, most of which are carcinogenic. You can see the compound here, a nitrogenous compound. These are enriched actually in tobacco smoke. It's one of the reasons that smoking is very harmful. Of interest, these nitrosamines can also be formed in the body following the ingestion of nitrate from drinking water. And the International Agency for Research on Cancer, which is part of the World Health Organization, classifies nitrate, therefore, as probably carcinogenic to humans. So nitrate in and of itself can be harmful outside of blue baby syndrome. And so when we look at the drinking water in Suffolk County, for example, I put this figure together. This comes from a paper that was just published last year, Temkin et al. And it shows across the United States, what's the concentration of nitrate in most people's drinking water. And you can see there's about 300, I believe, and 30 million people in the United States. And most people, their drinking water is less than 1 milligram per liter of nitrate. And you can see the next batch here, 1 to 3. But as our mean being out here, you end up with a situation where we have some of the highest nitrate in our drinking water here in Suffolk County across the country. And that World Health Organization subunit, that declaration that nitrate is probably carcinogenic is not just based on an aberration. And that is, there's been some very good research, and really what I'll say emerging research. If you look at the references I have here, there's been a steady drumbeat in the last few years of papers that have come out showing links between high nitrate in drinking water and cancers. Specifically, you can see here, colon cancer, bladder cancer, kidney cancer, and ovarian cancers. And when you see these studies, the high levels that they're talking about are usually at or around 3 milligrams per liter and higher. So we definitely have a high nitrate, and that's certainly a human health concern. But as a marine scientist, in my background in marine science, we also think about the role nitrate can play in surface waters. And I'm sure we're all well aware of the extensive water quality impairment that can occur on Long Island, particularly as we enter the summer months, as we're doing right now. This is just a map from 2018 showing the diversity of harmful algal blooms across Long Island, and also the numerous locations where there's been low oxygen events. And in all cases, these different events that have happened at different times, I'll just say this is really just a 4-month period in 2018, all of them can be linked either directly or indirectly to excessive nitrogen loading. Many of these events here are harmful algal blooms, and we have a plethora of different types of harmful algal blooms across Long Island that occur on an annual basis. One group shown here are the toxic harmful algal blooms that form different types of, for example, shellfish poisoning events, paralytic or diuretic shellfish poisoning events, or in freshwater, toxic blue-green algae. And then another class of these events that thankfully aren't harmful to humans, but can be lethal to marine life, including fish and bivalves. Again, the research has been clear over the last decade that more nitrogen can make these events either more toxic or more intense. And the toxicity event, 2 of the most common toxins that are made by these harmful algae, saxitoxin and microcystin, are nitrogen-enriched compounds. And so at a physiological level, with more nitrogen, these algae just get more toxic. And beyond the harmful algal blooms, fish kills have become a chronic occurrence on Long Island during summer months, just showing a highlight of some of the events that have occurred in recent years. But beyond these effects on marine life, as it turns out, the actual impetus for the Center for Clean Water Technology goes all the way back to Hurricane Sandy. So a little diversion here, but this is important for perspective. So another tragic event to hit New York. I'm sure we're all aware of this and how it occurred and where we were when it occurred. But during its occurrence, one thing that became clear was the role of salt marshes in protecting coastal communities. And so this image here actually shows, if you look very carefully, during this storm event, you can see these waves that are breaking out in the open waters. The quiescent water here is actually because these breaking waves are now within a flooded salt marsh. And that salt marsh, therefore, takes the brunt of these coastal storms. So there was extensive flooding all across Long Island during Hurricane Sandy. You can see that shown here. And I just want to zoom in to an example that was very clear all across Long Island during this event. And so what I'm showing here is a region on the South Shore, West Hampton, and specifically showing Moneybog Bay. And if you look at this region here, what you see are two peninsulas on either side of that bay. One still had its salt marsh intact, the other did not. And then if I superimpose next to that the actual flooding that occurred, what you can see is that this peninsula that still had its salt marsh intact had some flooding of some homes. But again, it was the salt marsh that took the brunt of the flooding. And by contrast, the parallel peninsula was flooded entirely. There was not really a region that was spared. And as it turns out, at about the same time, or within weeks of Hurricane Sandy hitting, a very important paper came out in the journal Nature that made it very clear, unequivocally, that high nitrogen rates and high nitrogen loading rates in coastal systems degrade salt marshes, leads to the loss of salt marshes, and therefore leads to enhanced vulnerability of coastal communities. So knowing all the potential effects of high nitrogen on coastal ecosystems, and particularly knowing the enhanced vulnerability to coastal flooding, it was in 2015 that our current governor, Andrew Cuomo, founded the Center for Clean Water Technology as part of a larger initiative to improve coastal resiliency. Having made it through Hurricane Sandy and seeing what worked and what didn't for protecting coastal communities, it was clear that having a center that was focused on improving water quality could play an important role in making Long Island more resilient to storm events in the future. So regarding the Center for Clean Water Technology, we have more than 24 people associated with the center, showing some of the names here. I won't belabor it, but I will emphasize that we've got a robust group of university faculty at Stony Brook across multiple departments: marine sciences, civil engineering, chemical engineering, chemistry, working with graduate students on all of our research projects and making great progress towards our ultimate goal, which is to marshal the public and private sector resources of New York State and beyond to develop more cost-effective technologies that will restore and protect water quality. And I'm going to start by talking about wastewater, but I will say that this goal stands for both wastewater and addressing wastewater issues on Long Island, and for improving our drinking water on things like 1,4-dioxane and perfluorinated compounds, and I'll talk more about that later in the talk. On the wastewater front, from the get-go, we set a goal that we called 10-10-30. That is that we want to develop on-site septic systems that reduce nitrogen below 10 milligrams per liter, that cost less than $10,000 per home, and have a life expectancy greater than 30 years. And I'm happy to say we've made some good progress on that already that I'm going to share with you shortly. And we're working with Suffolk County and actually all of Long Island to help address what you could call the 500,000 septic tank question. So what will be done with the 500,000 septic tanks that are currently polluting the groundwater and drinking water of Long Island? And you can see the majority of those by this number are actually in Suffolk County. The way the current systems work is as follows. If the home was built after 1972, that home would have a septic tank that goes to a leaching pool. If a home was built before that, it may only have what's known as a cesspool, which is a lot like this leaching pool. But either way, either system is not designed to remove nitrogen, and either system is discharging high levels of nitrogen into our groundwater with almost no treatment and almost no removal. And once it's in that groundwater, the nitrogen is very stable and then becomes part of our drinking water or discharges into surface waters. And I'll tell you that the average concentration of nitrogen in surface waters is usually somewhere about, on the nitrate front, could be as low as 0.005 or 0.001 compared to this number. And so now you start getting the idea of why this nitrogen is so high relative to what's going on in surface waters. And again, the current federal standard is 10 milligrams per liter. And there are epidemiological studies that suggest that even lower levels can be harmful to human health. So Suffolk County is addressing this and has really been, I would say at this point, a national leader in addressing the septic issues with a more rigorous program than almost any other county in the country, if not any county in the country, in working towards coming up with new septic systems. And they've already approved a series of systems shown here that meet their standard of 19 milligrams per liter. And so these can be installed in homes. The Center for Clean Water Technology is currently working on something known as nitrogen removing biofilters as an alternative septic system. And you can see here they're meant to be retrofitted onto existing systems by simply adding a pump chamber and then the nitrogen reducing biofilter. These systems, these NRBs as we call them, are essentially drain fields, which is a common disposal method for wastewater, on-site wastewater across the country and across the world. And that drain field purposely being underlain by a layer of sand, and a layer of sand mixed with another very natural and common product on Long Island, wood chips. And so with these two very common natural products, as a side view here, they're meant to promote two different chemical reactions to transform the ammonium in the wastewater into nitrate in that top sand layer where there's lots of oxygen. And then in that lower layer, by having the wood chips, that lignocellulose from the wood chips, converting that nitrate into nitrogen gas, which represents 80% of our atmosphere and is perfectly harmless. We actually have three different designs for these particular systems. I'll just show them very quickly. You can see the one here. The idea is that there's a liner underneath that lower layer. That liner helps keep the system saturated with wastewater and assures that the oxygen levels will be near zero, which is what you need to promote denitrification. And so that's shown here. A second system we also have been trying has no liner. So this is a less expensive system to install, a less complex system to install, gives us a little bit less reliability or at least certainty that the oxygen levels will be zero, but you'll see the performance so far has been good. And then the last system I'll talk about is our wood chip box system shown here, which has that layer of sand that then gets delivered to a tank or box that's filled with wood chips, giving us assurance that the wood chips are fully functioning. The box can actually be located at the same height as the wastewater. We can then replace those wood chips if ever, if that were ever needed. And so as it turns out, we've been working on these systems for quite some time. And in 2016, we actually installed one each of these systems at the Massachusetts test facility. And they've been running for about 3.5 years here. And what we've seen is they have continually generated very low nitrogen effluent. You can see here, this is the average level over about 3.5 years. So first that shows you the performance has been good for 3.5 years, and they're getting it consistently on it, or on average below our goal of 10 milligrams per liter, and much lower than the county standard of 19 milligrams per liter. After only a year or so of having this done, this data here, we then collaboratively work with Suffolk County to begin to install our systems across Suffolk County to essentially eventually make them approved to be used in individual homes. They were first put in as experimental systems. And so we have some data here from a series of our systems that we've installed in different locations across Suffolk County. And I'm putting in 2 lines here. One is the 19 milligram per liter standard by the county. And the red is our own personal goal of 10 milligrams per liter, the center's goal of 10 milligrams per liter. And you can see in almost all cases, we're below both levels. Single exception being a home that seems to have extremely high levels of nitrogen, and we're confident as we enter the warmer months that these levels will get below there. And again, for the county approval, we need an average of 19 milligrams per liter. We're confident we're going to get that across all 3 systems. But in very good news, when we compare the way our systems are performing relative to other systems that are have been installed and piloted in Suffolk County, our performance has been very good. And so these are different systems from different companies that have been installed and tested in Suffolk County. You can see there are several that have been approved, the ones in green. So those can be installed in any given home. And our performance on average has been better than those systems. And we're hopeful that that'll remain and that in short order, those will be available for installation. But to give my introduction, of course, you worry about nitrate, but there are other things in wastewater that we need to be concerned about since the wastewater is being deposited into our drinking water source, our groundwater. And so we have been looking at things like, for example, drugs and pharmaceuticals. So in work that we did on our 3 systems in the Massachusetts Test Center, what I'm showing you here are the concentrations, for example, our line system, concentrations going in, concentrations going out, and the percent removal. And so what you can see for these drugs and pharmaceuticals, some of which I'm sure you recognize, we're getting better than 90% removal almost for all of them, in some cases 99% removal. We've also done this testing in Suffolk County. There's a lot of compounds to look at here, but they're all organic contaminants that we don't want in our drinking water. And it's showing the percent removal, the dots are removal that you get in a traditional system or in a sewage treatment plant. And the bottom line is we're getting, in many cases, that 90% or better, and in other cases, we're performing, or in all cases, we're performing at or significantly better than a sewage treatment plant would. And again, looping back to a particular compound of concern, 1,4-dioxane. Again, this is an expected carcinogen as defined by the EPA. And so I'm just showing some data on the performance of just one of our systems with regards to removing this compound. And I'm going to put in here the currently proposed drinking water standard for 1,4-dioxane. And so what this data is showing is that this particular installation, the water coming out of the home is very consistently at or above that new standard of 1 part per billion. But as it turns out, the effluent is almost always below that level. And so what our systems are doing then is taking water that doesn't meet the standard and transitioning it to a level significantly or at least markedly below that standard. So we see great hope for installing these NRB systems across Long Island. I will mention we have a collaboration that we're very excited about with the Shinnecock Indian Nation. They happen to be located across the street, literally, or across the pond from the Stony Brook Southampton campus. And as you talk to them, they'll tell you that they've been caring for the environment for 1,000 years. And they want to protect the marine environment around them that surrounds their nation on Shinnecock Bay. And they want to protect their drinking water. So they'll be installing 10 or more of our NRBs across the nation there, beginning in the second half of 2020. So we're excited about that collaboration. And some final updates on the NRBs. We're now getting quotes that are in the range of $20,000 to $25,000 for these systems. So we have not met our goal of $10,000 for these yet, but the prices are coming down, and we believe as there are more installers, they could come down further. And importantly, Suffolk County and some East End towns have grants that actually can cover almost the full cost of these installations. Our systems were originally in something known as the experimental phase. We've are passing the bar to now get into what's known as the piloting stage in 2020, once sampling starts again. And therefore, we believe that in 2021 and 2022, we'll be having each of the 3 different systems advance to what's known as provisional approval. Beyond designing these individual on-site systems, I just want to very briefly mention some exciting news that will come out tomorrow. So you're getting an advanced view of this today, and that one of our scientists entered a challenge with regards to EPA for developing a sensor to measure nitrogen, specifically nitrate and ammonium, separately in wastewater. And the challenge had a series of specifications with regards to how the design should be, with regards to how long it should be out, with regards to detection limits and the like, and with regard to the cost. And Dr. Ching Zhu at the center has developed this sensor here, and tomorrow the EPA will announce that he actually won this sensor challenge. And so I won't go into a lot of detail here, but if you're a scientist, you see the response of the system relative to concentrations of nitrogen, you see the correlation coefficients, the recovery of standard reference material, the precision of the units, and their analytical range. These are really remarkable units and really like nothing else that's on the market, we think. And these are specifically designed to be installed at homes so we and others can track the performance of these systems. So that's one of the benefits of being located at a great university like Stony Brook. We've got great minds who can innovate and invent great systems and great sensors such as the one here. Other ways that the center can innovate is through our new wastewater research and innovation facility that was opened last summer. You can see the ribbon cutting here with many of our elected officials and our supporters from the DEC. And so this facility receives actual wastewater from a pump station that in Stony Brook. And so as it turns out, it's very hard in an experimental setting to recreate the complex biological and chemical cocktail that is wastewater. And if you don't have those components, particularly the biological component, any experiment that's done to test how something is working really will be missing the boat with regards to how a particular system may perform. It may perform well when you don't have the microbes that are involved in wastewater, but once they're there, everything is different. So this system is plumbed with wastewater. Here's a view of what it looks like on the inside, where we've got experimental systems shown here. There's actually two separate trailers. These individual columns are set up to mimic some of our NRBs. We also have an outdoor area for in-the-ground installations I'll talk about momentarily. And we're using this to perform research to optimize our nitrogen removing biofilters and also to minimize their costs. And part of it, you can see, is by experimenting with dosing rates, different types of media. But we're also moving on to something we call our next generation nitrogen removing biofilters, with the idea being that can we take the technology that we're using in the first generation systems, shrink it down into a prefabricated unit that could be installed at a significantly lower cost and sort of to bring down the cost, bring down the footprint, but then also achieve the same performance. And so Frank Russo, the Associate Director for Wastewater Studies at the Center for Clean Water Technology, has designed our intermediate nitrogen reducing biofilter. We call it NRB 2.0, or I think now we're on the 2.1 actually. And this particular unit, you can see, is meant to be quite small, 4 by 6 by 10. And we're experimenting with this at the test facility. And we're specifically, you can see the different parts of it here. Within experiments, this particular unit will involves continuous flow. It has recycling, which our traditional systems don't, and it has some pre-aeration, pre-aeration tank before the system is dosed. And I won't go into all the details, but you can see in a very lengthy experiment, almost a half-year experiment, with different stages at which the system was sort of being ramped up. The influent total nitrogen amount, as you can see here, ranged somewhere in the vicinity, or you can see actually here as well, between 60 and say 30 milligrams per liter. But you can see here the effluent of the system has continuously been of a very high quality, very low concentrations of nitrogen. So we're excited about this. We think it holds great promise. Just one example, we actually have 2 other next generation systems we're also working on. And our wastewater research and innovation facility will play a key role here, because in the literally backyard of the facility, we will have the ability to put in test versions of this new NRB. And we're also looking to test, I'll shortly talk about drain fields, but also looking to partner with other companies that may want to install their technology at the center's test facility. We can test it using our New York State Environmental Laboratory Accreditation program. So we're accredited for measuring things like nitrate, nitrogen series, and all sorts of other contaminants. And so we can collaborate, therefore, with companies to see how their systems are performing, give them a sense of their performance, and also, via our scientists, give an indication of what potentially could be modified to make the systems even more efficient. One other thing I'm going to mention with regards to our NRBs is how they might be used or modified to be made something known as polishing units. So I have the word Article 19 here. Article 19 was or is the law in the health code in Suffolk County that was specifically designed to allow these innovative and alternative septic systems to be installed. They also have within them the regulation that after that system, the final wastewater, the wastewater has to go into a final deposition phase. And this final deposition can be just standard leaching ring or a drain field. But Suffolk County is now offering a $5,000 incentive for what are known as polishing units. So that is, after it goes out of the commercial system, can it go through a final polishing step that would get the nitrogen levels even lower? And so we're working on a couple of different designs for this. One is the denitrifying drain field. So this is a typical drain field, but slightly modified to be underlain with a layer of sand and wood chips that would get the nitrate levels even lower. And also, taking a page out of our NRB book, we are looking into simply wood chip boxes as polishing units. And we have some designs based on research that we think will make these very efficient to essentially attach them right onto an existing system and to potentially get the nitrogen levels very, very low, less than 3 milligrams per liter. At our wastewater research and innovation facility, Dr. Stuart Waugh has been performing experiments to test different types of wood chips. Different size barrels that he's using here are meant to mimic different size wood chip boxes that then would indicate different residence times of the wastewater in the boxes to assure that the levels get as low as possible. And actually, this experiment couldn't be going better in that he's found out exactly the residence times that are leading to high nitrogen levels and the ones that are leading to the low nitrogen levels. I mentioned 3 milligrams per liter. And yes, we can get that with the proper design. And with not being properly designed, we end up with a system that is giving significantly higher levels of nitrogen. And importantly, the type of wood chip it looks like, consistent with what other researchers found, doesn't necessarily matter. But we do think that these wood chip boxes can be an important solution for particularly in areas that are very sensitive and we need to get the groundwater nitrogen levels as low as possible. These polishing units may be a great solution. We've actually also already installed some of these. So we had a great collaborative project with the Spring School and the engineering firm H2M. H2M was already installing a alternative septic system for this school. And they approached us because that school is located right on a sensitive water body in East Hampton. And the school was actually interested in getting nitrogen levels as low as possible. So what you're seeing here are actually a series of wood chip boxes that will be used as polishing units. They've already actually been installed and are receiving wastewater in order to get, again, those nitrate levels as low as possible. And we think that this is important. Schools, the big focus in addressing wastewater to date has really been on addressing individual homes, but schools are certainly a concentrated and potent source of wastewater nitrogen. And therefore, we think that working with schools and getting their systems upgraded are important as well. And that's why we're working collaboratively with the West Hampton Beach School District and the town of Southampton to help them design a system that will get nitrogen levels as low as possible. And we'll be shortly moving into the design phase of that project. Moving away from our nitrogen removing biofilters, I'll just mention a few other approaches the center is taking with regards to wastewater, and one is constructed wetlands. So constructed wetlands have been used for a very long time for addressing wastewater issues. They can be made as near passive systems, and we have done some experimental modifications of normal systems to get the nitrogen levels within our goal range. And they can actually be beautiful habitats. You can see this front lawn here. That's actually a wetland system. We've installed a system at the Nature Conservancy, their upland farm facility in Cold Spring Harbor. And you can see, again, it's a beautiful system that actually is populated by some beautiful insects that are pollinators. So it actually becomes a habitat. And we're working with Suffolk County, and we've created something known as a guidance document that will then be publicly available to the point where these systems can then be installed by residents, and it will take these systems out of what's known as the experimental phase and put them right into the piloting phase for innovative and alternative septic systems in Suffolk County. So everything I've talked about so far has been addressing wastewater at homes, but I'm just going to briefly transition to another approach we've been working on, something known as permeable reactive barriers. And these are specifically designed to be put into the ground to intercept plumes of high nitrogen groundwater before they discharge into surface waters, with the idea being that you can then put a barrier in that goes literally through the groundwater that's permeable, typically made with wood chips. Needs to be designed at the right permeability, also the right width, but when done so, they can be very effective at removing nitrogen. An example of this is a test cell that Cornell Cooperative Extension has installed, and we've been collaborating with. It's on Shinnecock Bay in Hampton Bays. And this particular system we've been monitoring for several years, and it consistently removes more than 90% of the nitrate that's in the groundwater before it discharges in the surface waters. And this design of putting wood chips, essentially a layer behind a bulkheading, we think is a really good idea because, as many of you know, across Long Island, bulkheads frequently break down, degrade, and need to be replaced oftentimes with, say, something that's new here, maybe made of some sort of plastic material. But the big expense with regards to installing a bulkhead PRB is actually in the construction aspect. And the idea that you have to have heavy machinery to put in, to hold back the land, to support the land, to put in the new bulkhead. And when that's being done, it may be an opportunity to put in a PRB so that any groundwater that would discharge to and through the bulkhead would be denitrified and have nitrate removed as that occurs. And in fact, we have an exciting project coming up at the Davis Park facility on Fire Island, being led by Dr. Nils Volkenborn at the center, where we'll be doing just that. They need to replace this bulkhead, and it'll be done with wood chips behind it, and in order to remove as much nitrogen as possible. So beyond addressing the water before it discharges into the surface waters, I told you in my introduction that the center is founded on the principle that we're covering the full water cycle, and it's not just our surface waters we're worried about, but we're very also concerned with regards to drinking water. And again, about a year after the center was founded, Governor Cuomo reached out to the center, seeing the progress we had made, and asked if the center could, in addition to addressing the wastewater issue, could we also take on some drinking water issues? And of course, we were pleased to do that. And I have to just note, of course, Governor Cuomo is in the news all the time these days as being an incredible leader through these very difficult times we're experiencing, shown great leadership, I think, both at the state level and even nationally. But I will say, before he was this great national leader and guiding us through this current pandemic, I will also say that I've always considered Governor Cuomo the best environmental governor the state has ever had. He's always been very forward-thinking and forward-looking with regards to being protective of our environment. The center is evidence of that, but it's on other issues as well. And so, but the first issue that he had asked us to consider addressing was this compound 1,4-dioxane. Again, pointing out how potent the levels can be in some places in Western Suffolk County and Nassau County. And I mentioned before, with regards to 1,4-dioxane, there's a pending state standard of 1 part per billion, 1 microgram per liter for 1,4-dioxane. Well, we have multiple water supplies in Long Island that are well above that. And the water suppliers themselves are wondering, how are they going to be able to get the levels down below 1 ppb? Typical technologies don't remove that compound. That's one of the reasons this is such a troubling compound. You can't filter it out. It doesn't get removed by a carbon filter. So you need to think about alternative approaches. And so that was the real focus of the center, for the center to start with regards to drinking water. And specifically, this first phase was to do some pilot testing with water suppliers. So what technology could be brought to bear to get this compound out of our water supplies? And then concurrently to perform some research here at the university in order to figure out how the treatment systems could be tweaked to be optimized. And so the biggest initiative to date has been working with, you can see 4 different water districts here: Plainview, Green Lawn, Suffolk County Water Authority, and the Hicksville Water District. We gave grants to these individual water districts, and with those grants installed 4 different types of systems, UV-based systems, and they're specifically known as advanced oxidation process systems. So the idea that the UV light working with a catalyst can then degrade the 1,4-dioxane. And of course, we're also doing the research with these water districts to make sure that we're not creating a worse problem with addressing the first problem. And that is, we don't want to see any byproducts that may be equally harmful to human health. So again, different systems, the 4 different systems with different configurations, all of them UV-based, and then UV with different catalysts in order to help break down the 1,4-dioxane. We also have done our own research, and we can see here a publication that just came out in the journal Water Research, looking at how different properties of water affect the ability of these advanced oxidation process units to break down 1,4-dioxane, as well as understand the generation of byproducts. So we think all this data is going to be extremely useful. We're going to be releasing that to our Technical Advisory Committee and the New York State Department of Health in short order. And then thereafter, this information will be, we believe, incredibly important to the water suppliers across Long Island as they look to install these advanced oxidation process units in a way that's going to minimize their costs and maximize the removal of 1,4-dioxane and minimize the likelihood there are any byproducts that are harmful that are created. A final drinking water issue that we're addressing are perfluorinated compounds. These have become ubiquitous in water supplies across the globe. And the poster child for the ubiquity of these compounds is that there are polar bears in the Arctic who have high levels of perfluorinated compounds in their blood. And so these, you can see, are chlorinated compounds. And they've been extremely important in firefighting foams. They're also put on, say, Teflon pans or on, say, Scotchgard on rugs. They resist water, and they've been used for a long time and have become ever present in humans and household products. You can see the very wide-ranging health effects that they can have, none of which are good, and you can see that there's all sorts of different ways that we can be exposed in utero through childhood and into adulthood. And so in the last, I'd say, 3 to 4 years, there have been a series of water supplies on Long Island that have come up as contaminated with extremely high levels of this compound. Right now, the New York State has a pending standard of 10 parts per trillion for the perfluorinated compounds in drinking water. There are some locations on eastern Long Island, for example, that have come up with 11,000 parts per trillion of this compound. So it's a serious issue. In some places, the people have had their own wells, and those wells have been replaced with public water. But in other places, it's even showing up in and near public water supplies. And again, in the last few years, it's been every few months that a new location has come up. So New York State turned to the center to help address this issue as well. We got funding a couple of years ago through the state and the DEC in order to set up a test center at the university. And you can see we've done that. We've purchased a liquid chromatograph tandem mass spectrometer shown in our lab at the university here. And we've just been certified to perform by the New York State Department of Health to perform analysis of perfluorinated compounds. And so now we're at the ready to work with the DEC and hopefully Suffolk County, other places that need it, to get a handle on the scope of the contamination of our water supplies. And this new method that we've been certified for focuses on the compounds we always hear about, so things like PFOA and PFOS, but also includes 18 other perfluorinated compounds. Because the one of the issues at hand here is that it's not just the PFOA and PFOS, but there are many other perfluorinated compounds, many of which have health effects that are as bad as or potentially worse than the two primary compounds. So we'll be able to measure 18 of these, again, with our certification using the US EPA method 537.1. And beyond doing the analytical work, we're also now engaged in a new work plan with the New York State Department of Health that's specifically going to focus on some of the shorter chain compounds, which have been largely ignored, but may also be important with regards to contamination and health effects. We'll also be performing research to understand how best to remove these compounds from our water supply. And Dr. Arjun Venkatesan also has funding from the Department of Energy to look at something known as electron beam removal of perfluorinated compounds, as well as 1,4-dioxane. And he's working at the Fermi Lab, a national laboratory, to use this electron beam to see, might this be a compound, might these be compounds that can be removed by electron beam technology. So the final thing I'll just mention is the fact that the Center for Clean Water Technology is also now responding to the ongoing COVID-19 pandemic, and specifically doing so by engaging in a research project that uses the approach of wastewater epidemiology. And so wastewater epidemiology is founded on the principle that, as it turns out, sewage treatment plants are great integrators of human populations. Now, not all of Long Island is sewered, but there are, of course, many areas that are. And in communities that are sewered, the sewage treatment plant is collecting the wastewater from everyone in the community, and therefore can give you an unparalleled view of what's happening in a given community. Research most commonly to date has been, for example, looking at drug consumption and looking at the amount of drugs being used per day. And again, this is an initiative being led by Dr. Arjun Venkatesan. He's published on this before. And so when this epidemic began here specifically and moved to New York, we began to think about the idea of how could this principle of wastewater epidemiology, how could that be applied to the ongoing pandemic? And it became very clear in the news within, I think it was in early March, that the virus is not only infecting people, but once people are infected, it passes through them and it ends up in wastewater. And as we're all well aware, in the current pandemic, there are people who are very symptomatic and tested positive, but we also know there are many people who are asymptomatic and just simply carriers of this virus. But the problem is that due to the complexity of testing, and frankly, in some cases, the lack of ability to test, we really don't have a handle, I would say, on either one of these populations, but certainly we have no handle whatsoever on the asymptomatic individuals. And so what this project will seek to do is to, again, using wastewater epidemiology, to collect that integrated sample from the entire community from sewage treatment plants, so we can track over time the appearance of the virus in the wastewater. And again, whether you're symptomatic or asymptomatic, the assumption is that both populations actively, or not an assumption, it's known, they both have the virus, and the virus does pass through individuals, and that will be shown within the wastewater plant. Now, and I want to emphasize that this approach, of course, is very important, and what we expect is a curve like this. We've all heard about the idea of flattening the curve, and hopefully we're now on the downside of this curve. And we've been collecting samples, so we believe we're probably going to be able to capture maybe a little of the upside and certainly all of the downside. But what we see as being very important, as I'm sure people have seen in the news, there's the possibility of a second wave of this virus. And if one considers the way wastewater treatment plants operate, it's quite possible that that second wave could be detected via the wastewater epidemiology approach of tracking the virus. It may, if the levels are very, very low, say by the end of summer, a sudden uptick in the wastewater would be a signal that the virus has returned to a given community. And that's very important because I'm sure many of you know, people, even when people become symptomatic, they are infected and asymptomatic for an extended period of time, a week or even more. But they would be shedding that virus, and that will show up in the wastewater. So this may be a very important tool moving forward. And so we have been collecting wastewater samples from different treatment plants here in Long Island, and we're looking to expand that work. So we have Arjun Venkatesan's contact information here. And so if you wanted to contact him because you run a sewage treatment plant, you'd like those samples analyzed, we can do that. And so we'll be moving forward with this, and we're hopeful that this is going to be a useful tool for our communities moving forward. So to conclude the presentation, what I've shown you today is that nitrogen removing biofilters remove more nitrogen than other advanced septic systems while concurrently removing other organic contaminants. We're getting about 90% removal of both classes of compounds, and we're consistently getting below 10 milligrams per liter in our first generation NRBs. Our next generation systems, experimentally at least, are getting down to 2 milligrams per liter or lower. And we're hopeful that these will be even smaller and less expensive than our first generation systems. We've developed polishing units that can be installed in any home for any commercial installation that we think will consistently get nitrogen levels below 5 milligrams per liter. Potentially, experimentally, we're showing it's actually less than 3 milligrams per liter. Moving forward, our pilot installation of advanced AOP have provided information to help water treatment facilities to meet their future drinking water standard for 1,4-dioxane. And we're now a certified laboratory that will help test and identify the extent of perfluorinated compound contamination across Long Island. And then lastly, we are engaging in a wastewater epidemiology study to track the novel coronavirus and hopefully going forward help detect any second waves of infection that might show up in our communities. So with that, I'd like to thank you for your attention. I'd like to thank New York State for support, both the DEC and the DOH. We've gotten support from the Bloomberg Foundation as well as the Roush Foundation. We have a Twitter account. You can now follow us at NYS CCWT, New York State Center for Clean Water Technology. We have our website here, and you can also join up our email list. And as the governor has shown via his leadership historically, and even today, we are rising. As a state, we will continue to rise to address the current challenge, and then moving forward also to address the challenge of protecting and restoring our water resources. And with that, I'm done, and I'd be happy to take any questions. And I don't know if we have any questions. Hillary, do we have questions that we want to address?
Nothing from the email box.
Okay. Well, I know we're on a little bit of delay, so we may not get to any questions. Again, if people have questions they want to very quickly send an email to ccwt@stonybrook.edu. You're welcome to do so. I'm not sure the time frame within which we would get those questions. And I guess I will also go back, make sure that people in the meanwhile. Yeah, so there's our email address for questions, as well as our website, our Twitter address, etc. So I may get off the hook easy this time, as we do not have the question set up as a chat. But with that, I'm very thankful for everyone's attention and their interest in the center. And I'll certainly say, if you do have questions and we don't get them today, you're welcome. If you do submit them, we will make our best effort to address all of your questions in the future. So go ahead and even if you watch this later on video, you're welcome to submit your questions, and we'll seek to answer those.
Chris, questions are showing up in the chat, actually.
Okay, those are probably internal questions, but we can look at those as well. So the question was a little bit more information on the polishing system. Thank you for your question, Bernard. And rather than going up and showing the slides, maybe I'll just simply say that, yeah, the polishing units are designed to be an add-on to any existing IA system. So as it turns out, as I mentioned, there's already been about a half a dozen systems that have been approved in Suffolk County, and several, I'd say most of them get around 19 milligrams per liter. There are a couple that get to around 10 milligrams per liter, maybe slightly above. And what our research has shown is that for many of these systems, a add-on unit can get those levels even lower. And again, we have a few different designs. We have our Woodchip box design, which is the most advanced at this point in time. And we're just about ready to go on that. And so we think that'll be a useful solution. And we're also looking to our denitrifying drain fields. But again, these would go in tandem with any commercial system to help those alternative systems get down below, significantly below 10 milligrams per liter. And we think for much of the year below 3 milligrams per liter. But thank you for your question, Bernard. Any other good questions, Hillary? Or we can, like I said, people can always email in their questions. At that point, we can ask them to, we'll certainly answer them. Okay, well, with that, I will say a sincere thank you to everyone watching for their attention. And please do, again, I encourage you to reach out. You can always email us. You can hit us on Twitter, and check out our website, and we'd be happy to speak with you further. So with that, I think I will end it, and thank you for your kind attention, and stay in touch. Take care, everyone.
Thank you.
You're welcome.